Hello everyone, hope you're doing well, because today I have a very interesting topic to teach you, which is how to configure Spring to work with multiple data sources and switch them at runtime using just annotations. Also, I have prepared two simple examples which make use of this feature, so let's get started. Alright, so starting with the first example, it's a bit weird, you probably won't see it in a real application, but for our case it will be very helpful. Here I've opened my MySQL, and we have two databases which are identical, and in that user table they both have one entry. This one is saying MySQL1 and this one is saying MySQL2, and on top of that we have Microsoft SQL Server database, and the table here is again identical, and we have SQL Server username here. So the goal of our application is to have one entity and use annotations to let Spring know for like which method, which data source to be chosen. That's the first example, and let's jump into the code to implement it. I've already added some of the code just not to waste time, so let's go through that. So this is the configuration. We have the primary database, the secondary database, and the third database. So the first two are from MySQL, and the third one is for Microsoft SQL Server. As you can see, I've added a different driver here for those. So yeah, let's go to the POM file. I've only added few dependencies: Spring Data, Microsoft SQL Server driver, and MySQL driver, and Wombok just for better readability. This is empty for now. We're going to obviously implement it. This is the starting. This is the main method. This is the entry point of the application. Here we're going to do some testing and stuff like that. This is the user entity. We have just ID and username, which is more than enough for the example, and the user repository, which is empty. Okay, with that being said, the first thing that we want to do is we want to convert those three data sources into some sort of configuration. So I will start with an enum file, and I'm going to call that data source type. Okay, so the data source type will be primary, and I'm just gonna add the name here, just primary. Secondary, and the third one, I always forget that word, excuse me for that, but like that, tertiary. Okay. Like so. Okay. Final name, and let's just add some annotations, getter and required Rust constructor. As I said, I'm using Wombok so that I don't have to write unnecessary code. So yeah, this is our enum. We're going to use that to basically configure more easily those properties and don't have to hard code it later. I'll show you. Now we're going to use that in our data source config file to build the three data sources. So private map of the object, and I'm doing that. I'm going to probably explain it later, but that's what's required by Spring. So build data sources, and here we're going to say now data source type. So for each data source type, we'll have to build one, but before that, let's create our result file. So this build source type. Sorry, source type. Data source. So here's where we're going to actually build the data source. We can say actually, yeah, carry config. So config set JDBC URL, and actually now we're going to have to import the environment service from Spring. So private final environment, so that we can access the environment variables. So environment, and we can just add the required args constructor, so we can outwire that. So the JDBC URL, that should be this environment get property string format, and now we need basically this thing. So copy paste here, but instead of primary, we're going to use source type get name, so that it works for whatever we pass it here. So JDBC URL, set username and set password. That's also pretty much the same. So that username dot password, and this one as well. So username, password. I'm just gonna quickly rename this to env, so we have more space here. All right, so the driver class, I set driver class just like that. All right. Okay, config set auto commit. We want that to be false, and yeah, I think that's pretty much it. Now we just have to return the data source passing the config, and that should be it. So here in that method above, we need to say result, put source type, and this build data source from that source type, like that. We don't need that, and return the result. So yeah, now basically what we, as you can see, what we did is we automated the process so that now we don't have to repeat that 3 times, which is great for us. And next thing now is to create a bean and say public data source get data source, like that. So the first thing we need to do here is say this build data sources. This is the data sources, and here we actually need to return a class called routing data source. It's coming from a class called abstract routing data source, but we'll create our own instance of that. So let's go ahead and do exactly that. All right. creating the class. So routing data source extends abstract routing data source, and it has to implement one method. Method is called determine current lookup key. What this thing does is every time a transaction is being processed, you have to every time a transaction is being processed, basically this method is being called by Spring, and here we have to hint which data source we actually need to use, and we have to store like which is the current data source. So we're going to do exactly that with constant field here thread local from stack from data source type equals new thread local. Yeah, sorry, forgot the name. I just call it context like that. So why use thread local? We use thread local because obviously Spring and the whole Java web environment is an asynchronously built. So we need to make sure that we're talking about one thread only, and this does exactly that. Everything that's kept in that field is only for that specific thread. We want to return whatever is in the top of the stack in that method. So first I'm actually going to create private static stack of data source type. Get context, and here I'm going to say if that's no, stack like that, and then return, basically preventing no pointer exception, just to be sure. So get the context here. So let's say if the context is empty, want to return no, otherwise return, or actually want to peek. So peek basically means that we're going to get the latest one, and I actually want to log that, so using one block to get the logger, and let's say log info, let's say chose data source for the next transaction, like so. So peek, this is the source type, and return the source type. Basically doing that for later when we start testing. Okay, so apart from this method, we actually need to be able to make changes to that property. So I'm going to create two methods. The first one is public static void set, like that, and we want to add the data source type, and the other one is going to be restore ctx. All right, so the set ctx, we need to just say get the context and push data source type, and for the restore we need to say get ctx. So if ex is if it's not empty, we need to say pop. Right. So basically, the way we designed that will allow us to nest those data sources. That what I mean by that is, let's say you can want to call the first database in a transaction, then call the second database and the third, all within their own transactions, and this will actually allow us to do just that, doing it that way. And when we go back from the last transaction, when we restore the context, we'll not lose our previous data source. So that's why we're going out using that approach. So now let's go back to the data source config, and here we can finally say routing data source equals new routing data source. We want to say set target data sources, and that's where we need to pass this map of object and object. And routing data source set default target data source, and this is the basically data source the data source it's going to use when we return no here. So the default data source for our case is the primary one, so data source type primary, which is going to pass that here. And we want to return the routing data source. So with that, actually the configuration should be completed and we should be able to start the application. Let's see. All right, so the application started. Now the other thing left to do is actually create our annotation and make it work with every method that we put it on. And to achieve that, we're going to use an aspect, but before that, let's quickly create the annotation. I'm just going to add it to the config folder, so it's not really correct, but it's a demo, so no problem. So config routing, I'm just going to call it with database. I mix the name. So retention runtime target is method for now. We're probably going to have to extend it for the second example. And we want to make this annotation transactional, which what that means is every method which is annotated with this database automatically gets annotated with transactional. That's a good thing of that Spring has. It's basically, it allows you to nest transaction over annotation over annotation, which is really helpful for cases like that. And the other thing is we're going to create that aspect. We're going to call it database router aspect. So this is an aspect. It's also a component. I'm not sure what else it is. We'll find out. So want to say around. Okay. Public object proceed. The class here was proceeding join point, yeah, and the with database annotation, and that throws a throwable like that. So around annotation, with database. Basically, what this does is everything that's annotated with this annotation is going to be intercepted here. So here we need to do the following. We want to try, and we want to add a finally. So try, the first thing we add here is routing data source. We want to set the context, and the context is I forgot to add it actually, but going back to the database, to the with database annotation, data source type, or I'm just going to call it value. And we're going to default that to the primary database. So basically, the user will be able to add that annotation somewhere and just specify which data source he wants to use for that. So we're going to pass the value here. We're going to return proceeding join point like that. And finally, we want to say routing data source restore. So this is all in one transaction. So before the SQL call is going to happen, we're going to change the context. The SQL is going to happen, and finally, regardless if it throws an exception or it completes successfully, we're going to restore that to its previous state. That's pretty much it for the configuration actually. Now we can start playing around with that. So the first thing I'm going to do is I'm going to create a user service. And this user service is going to have a list of user find all, and I'm going to call it ds1 because this method is going to return the results from the first data source, and the second one for ds2 and this one for ds3. Now let's add an implementation, user service implementation. Okay, we're going to want private final user repository, like so, just to add the annotation. All right. So the data source 1 doesn't need any annotation, but I'm just going to add with database. The data source 2, actually we're going to have to add data source type secondary, and the third one we're going to obviously want the third one, and all of those can simply call one method, but obviously with different annotation everything is going to be different. So find all, return this repository, find all. So find all. All right, like that. Okay, now with that being set, we can go to the startup class and we can play around with that logic. So let's import the user service like that, and let's do the following. This user service, so 2 and 3. Okay, let's run that and hopefully all goes well. All right, so let's check the logs here and see what happened. So we chose the primary data source, and if you don't remember, this log is coming from sorry, I messed up something. So yeah, comes from here. And you can see that the result is MySQL1, which is the first database. And then for the second method, we chose the secondary and we got MySQL2. And the third was from Microsoft SQL Server. And as you can see, what we achieved here, basically, we call the code, and the code really doesn't care like if you're working with MySQL or SQL Server or whatever other database. It only cares about the business logic. So that's really great, and it really allows you to like separate the two things. One more demonstration for that is what happens if we nest the databases. So let's create such case quickly. I'm just going to call the method isDefUser find all nested transactions, like that. All right, it's going to be a bit messy, but we have to just do something to obviously make the example. So this one is going to be with database. Let's say this one is going to be from the secondary database, and it's going to say I'm going to need 2 more classes for that example. So user service 2. I'm just going to do it like that to save time. I won't create the interface. User repository, list of user, find all, let's say, and this is gonna be with database. The first one was the secondary, so this one is going to be the third, and we are going to have one final service. Going to be the number 3, and this one is going to be with nothing, basically with the primary one. So this is going to return user repository find all, like that. The second service is going to depend on user repository and user service 3. So users equals this user repository find all, and then users add this user service 3 find all. Basically that's how we are going to achieve this nesting. Let's see, what's that user, and what does it add all? Yeah, add all, sorry. So returning that, and in the main user service we're going to have something similar. So this user repository find all users, and then users add user service 2 add all user service 2 find all, and return users. Okay, just let me do a quick sanity check, see if it should work like that. Looks like that to be okay. So going back to startup, I'm just going to comment out those and say system out print this user service find all with the nested transactions. Okay, I'm starting it, and let's see what we get as a result. Okay, so that's something interesting. As you can see, we chose the secondary data source, which is basically the first annotation here, and we like stuck with that. And the result is, as you can see, we only get data from the second data source. And the problem is that we're actually in the same transaction. That's why we didn't trigger the method here, routing data source. We didn't trigger that method. So how we can fix that is, if we go in the with database annotation, here you can see that where we added this transactional annotation. What we can do is just add a propagation requires new, and let's run the application now and let's see what happens. Okay, so as you can see, it's a bit different now. It works as expected. So we chose the secondary, we chose the third, and we chose the first. So you can see the second user, the SQL user, and the first user. So with that being said, this is the example completed. As you can see, it works like wonders. Basically, you just you just add an annotation and voila, you change the data source. For a second example, I went ahead and already added a few classes. Nothing else is modified, just this account folder was added. So here's the entity. It's pretty simple. Again, it's ID and account name. We have the account repository, the account service, and the implementation. So the different thing here is that we don't have the account table in both of our MySQL databases. We only have it in the Microsoft SQL Server. As you can see, accounts, and there's only one row called SQL Server account. So let's go ahead and try to query this. So requiring that service, like that. Find all. So restart. Alright, so we get an exception saying that table accounts doesn't exist, and that's fine because we know that, and we can fix that with saying with database and choosing the database which has this thing. So we run again, and you can see it works fine. We get the result, but the problem here is that this only works when you annotate the service. But what happens if you do the following: account repository and account repository find all. I just found a typo here, so let me just fix it. Right. And one more thing here, just not to restart every time. Right, so running it again, and you can see that the first time we got the result, but the second time obviously didn't work because the account repository doesn't know by itself that it belongs only to that third data source. So with the second example, we're going to do just that. We're going to let's print no once and like forever during the lifetime of the application that account repository only works with Microsoft SQL database, and that database in particular. Okay, the first thing we need to change is the with database annotation. So it used to work only on methods, but now we have to change that and have to say method and type as well. That's the first thing. Now with being able to be set on types, we want to go to the account repository and say that this repository is going to work with this database. So in our case, the third one, like that. And that by itself won't do anything. For now, we'll have to do the configuration by ourselves. Also, I'll have to add the repository annotation here and give this account repository a different name. And we're going to now copy that name, and we're going to create a new class here called routing repository config. It's configuration, and here is where we're going to configure this repository, or however many repositories we have that need such configurations. So we need to import that. So private final account repository, like so. This time I'm going to use a constructor because I want to add a qualifier here to specify that we're talking about this particular repository. Actually, this can be avoided, but I don't want to do any wombo configurations. So moving forward, now we want to create a bean here, and this bean has to be is going to be the primary one. So add a primary annotation, public account repository, like that. Okay, and here we need to create our own repository based on that, the one that we received. And like in short, what we're going to do here is we're going to wrap all the methods that this account repository has, and we're going to reroute them to the annotation, to the required data source, which is specified here. Right. Private, and this is going to be generic. So E for entity, ID for the ID of the entity, and then T extends JPA repository of E and ID, and we're going to call this create proxy instance. We're going to receive the repository like that. Probably messed something, I guess. Yeah, we'll actually have to return T, and here, not sure if it's going to work like that. Let's see, repository. Yeah, that can probably work as well. Okay. So we need to get the type of the thing that's coming here. So repository get class, and now get interfaces. We want the first one. So what we're doing here, first I should probably explain why we need that method. Here we have to say this create proxy instance of this account repository, like that. So basically what we're doing here is we're creating proxy of that, and here we receive that implementation of a given repository. And when we say repository get class, we don't get the actual interface, we get the concrete implementation that Spring does for us. That's why we need to say get interfaces. And here we receive repository type. So that's our repository type. object instance. For now, we will keep that as no. Try, and we can catch the exception. Here we can say, oh, I haven't added a walk. So standard walk for J, walk error. We just want to walk that. It's a good practice to walk some things like that. So error while creating proxy for class like that. So add here repository type, and then also add the exception. And actually, it's going to be good if we rethrow that exception. So here we go. And finally, we want to return the instance. All right. So instance is going to be proxy. We want to use Java reflect one, so new proxy instance. It wants the class holder, so we're going to use the current class holder. Interfaces, so we want an array of interfaces. In our case, it's just one, so we're passing that. And the next one is the handler. I'm just going to pass lambda here. Like that. All right, and here we can cast that. All right. So in that handler, what we need to do is we need to do the same thing that we did in the aspect. Basically, change the context, proceed with the method, and then restore it back. But it's going to be a bit different because here we don't have a transaction, and we need a way to do that. So before that, actually, we need to get the annotation. So with database annotation equals repository type, get annotation, database of class. And actually, I would prefer to have that somewhere outside so that I don't spam it every time. So yeah, the idea here is, and I'm even just gonna go and say value. So data source type, like that. So we have that and we know what to use. And for this one, we're going to have to write a small service. I'm just gonna add it here. It should be in another package, but for the sake of example, transaction no helper, let's call it. That's going to be a component, and it is going to have public object run with transaction. We're going to annotate it with transactional. We want to use the propagation requires new because it won't work for nested transactions. And we want to throw an exception here, like that. Actually, it's not an interface, so I should probably implement it. And we should receive a functional interface, but I have to write my own here. So public interface, let's call it throwable supplier, like that. And I'll explain in a bit why. So we'll have public object supply throws exception, and that's basically why. Not public. I'm sorry, we don't need that. That's basically why, because the standard supplier doesn't throw an exception, and we want to throw an exception here. So that's a functional interface, and here we want to receive throwable supplier, return supplier supply. And that's it for our small transactional helper. Private final transactional helper. Add that for the constructor. This transactional helper run with a transaction. All right. And inside the transaction, we actually here I want to return that. I'm sorry. So inside the transaction, we want to say data routing data source, set the context, data source type, and my bad, that should be try catch, so like that. The return method invoke, and the repository instance and the arguments like that. And finally we want to say routing data source restore CTX like that, and we don't need that return, so we can simplify that. So basically what we did, each time any method of that given repository is being called, we intercept that, we run it in a transaction, and inside that transaction we change the context based on the repository's specification. We invoke the method, and finally we restore the context. With that being said, I guess it's time to run it and see what happens. All right, good news. Just to remind that the startup still uses the account repository, and as you can see, now both of them work as expected. And as you can see, those two were stuck together, and that's because here we have that annotation, and actually we don't need it anymore. So if we run it again, it should also work. Yeah, as you can see, we have a working logic here. So what we did, basically we made the repository, we added an additional layer to the repository, we intercepted each call and made sure that the proper database has been used. So with that being said, this is going to be it for that video. Hopefully you found it helpful. If you have interest in the code, it's going to be uploaded to GitHub, and I'm going to leave a link below. So thank you for watching. If you're interested in videos like that, you can subscribe, because I plan to add similar content for Spring and Java in general. Thank you for watching.